Hello, algebra class. It's me, Mr. Soto. I just pressed record. That's why I wasn't there originally. And so I'm going to give you some math here. I'm going to give you page 18 through the practice test. And so that'll finish up the teaching for this book. That's about a week and a half worth of work that I'm going to teach you, so you can take this and watch it for a while, do some of the work, and then continue on a little bit later. So that's the plan. On page 18, we're going to have some word problems here, which are always our favorite thing to look at. So it says on page 18, where the paragraph says, the Hawks still have a narrow edge over the Pioneers in this basketball game. They're leading 51-49. So the Hawks have 51 points, and the Pioneers have 49 points. Okay? It says the Pioneers have scored 30 times, the Hawks only 29. So far, neither has made a 3-point basket. Says how many 2-point baskets and how many free throws have the Hawks made? So let's do this. We'll say a basket and a free throw. Okay? We'll call a basket and a free throw as far as that's what we're solving for. We're going to put two equations together, run those two equations together, and we'll figure out exactly what they're asking here. So a basket we know is worth 2 points, a free throw is worth 1 point, and they've scored 51 total points, right? Because that's the Hawks, because the Hawks have scored 51. So we go 2b plus f equals 51. So what we have here is we have one problem. Now we have to create another algebraic problem to subtract from it. So we know that they've scored 29 times. So their baskets plus their free throws equal 29. So if you look at the board again, that's the value of a shot. A regular basket is worth 2 points. A free throw is worth 1, so it's just 1f. So 2b plus 1f equals 51. And then the baskets plus the free throws. Now, just like we learned before, let's go ahead and subtract. Let's just multiply everything on the bottom by a -1. The reason we're going to multiply it by a -1 is we want to get rid of the f, so we only have one unknown value, being the b. Once we find the b, we can solve for the f. So let's go subtract, subtract, subtract. I chose to multiply everything by a -1 because when I do that, I can actually eliminate the letter f there because f minus f is gone. Now I have 2b minus b is just b, and then 51 minus 29 is 22, if my math is correct there. So they scored 22 baskets, and they scored, so the baskets plus the free throws, 22 points in baskets, equals, that means they scored 7 free throws. So there you go. Yeah, because they have 51 points. Yep, because 22 and 22 is 44, plus 7 is 51, or the number of baskets plus the number of free throws equals 29. Either way you put it back in the equation, it works both times, and so that's how you do that one. You can do the next one on the Pioneers next to that one. I'll give you the next problem below that, where it says, Nikki said you'll never guess my numbers. The sum is 12, and their difference is 26. So let's go two numbers. We'll call one number x and one number y. Okay? So we'll make x the larger of the two numbers because we have subtraction in here, and you always have to have order in subtraction is going to matter. And so let me make sure I'm recording right now because I don't want to do this for an hour and then it not be working. 1 second. Oh, yes, it is recording. All right, so we're going to guess Nikki's numbers. She says their sum is 12, so x plus y equals 12, and their difference is 26. X minus y equals 26. Okay, so now we have two numbers. One of those numbers is x. We're just calling it that. You could use a and b. You could use any two. You could, number 1, number 2. You could do any of those things. We'll just call it x and y for simplicity's sake. So now let's do this. It's already set up for us because you have one that's a positive y and one that's a negative y, so those will cancel out. So you stack these on top of each other. This already cancels out without any changing at all. Now we have 2x, because it's not x times x, it's x plus x, so 2x equals, let's add these together, 26 and 12 is 38. And so divide by 2, x here is going to equal what, 19? So if x equals 19, all we have to do is now put this back into this equation to find for y. So y must equal a negative 7 then. So we have x must equal 19, y must equal a negative 7, and we solve for the problem, and you can do the next one there on the other side of the page. Let's go on to the next page, which is also a word problem. Mr. Soto just did half of your work for you on that page. Can you believe that? That's very nice of me, and I expect if we get back together in May, April's looking pretty dicey right now, but maybe in May, there's couple of classes in May, so we'll see what happens there, but I expect you to be nice to me. So look at page 19. A 96-inch board has been cut into 2 pieces. So we'll say we have a longer piece and a shorter piece. Let's say the longer piece is x and the shorter piece is y, just so we have just one letter representing those unknowns, or the 2 unknowns. So it says, together, x plus y equals 96. Right? Because it says a 96-inch board was cut into 2 pieces, so the total is 96. One piece is 8 inches longer than the other. So we'll say this is the shorter piece. So y equals x minus 8, right? Now these aren't stacked on top of each other. We're going to do this actually a little bit differently, and I'll show you how to do that. You could actually rearrange them and stack them on top of each other, but for this problem, we're not going to do that. We're going to use a substitution method instead. So watch carefully. What I'm going to do here is I'm going to take this y, and I'm going to substitute this y for it. Well, this y is the same as x minus 8, right? And then we learned that either side of the equal sign is the same. So you could take this y and erase it, and actually put x minus 8 in there. All we've done is substituted it. Let me do it again, show you what we did. If x plus y equals 96 and y equals x minus 8, y is equal to that, so we can put that right there. So we can go x plus x minus 8 equals 96. Now we're solving for x, which we know is the larger of the 2 pieces, right? Once we solve for x, we substitute x's value back into either of these problems, and you'll get the value of y. Very easy, right? So now we have x plus x minus 8 equals 96. So now we have 2x equals 104. Sorry, my brain's fried. Divide by 2, x is going to equal 52. So if x equals 52, then we're going to say, let's just plug it in right here, right? Y equals 52 minus 8. Is that 44? I think so. So y equals, so one piece is going to be 52, the other one is 44 inches. Okay? So that's how you did that problem right there. And should I do one more for you? That would be terrible, wouldn't it? I'll give you a hint. I'll give you a hint on the last one. Lynn paid 42 cents for a pencil and 2 erasers. Kim paid 91 cents for 5 pencils and 3 erasers. What were the prices of the pencils and the erasers? So you want P as the price of the pencil, E as the price of the eraser, and just go pencils plus, so 1 pencil plus 2 erasers equals 42. 5 pencils plus 3 erasers equals 91. Now you can stack those. That's probably the easiest way to do it. And get rid of either the pencils or the erasers. That would probably be the best way to do it. You could, I'll do it for you. Too nice, Mr. Soto is. Too nice. You want me to do it elimination way or substitution way? I can even do a y-intercept and graph it on a graph. And wherever those 2 lines intercept each other, that would actually be the coordinates for the x and the y. It's totally cool because you have 3 different ways to solve these things. And that's what they're showing you right now. So we have the pencils and the erasers. So a pencil plus 2 erasers equals 42. The 5 pencils plus 3 erasers equals 91 cents. Okay, so we only leave the 92 and the 42 is just without the decimals, even though it's cents, because that's irrelevant. We'll get to the end, we'll fix it. So there's a couple things we could do. I could get P by itself, meaning subtract 2e from both sides, then plug that in for this, and because that would be P equals 42 minus 2e, right? Then you can just plug that in here like this. Plus 3e equals 91. And then you've combined both of them together and you solve for it that way. That looks a little bit complicated. Or you could stack it like it already is. You have the P over the P, the E over the E, and the money over the money. So that's already set for us. You can either do one of two things. If you multiply the entire top by -5, what that would do is it would allow you to get rid of the P, because the -5p and the 5p would cancel each other out. Watch how I do that. So -5p, -10e, and then you have 42 times 5. I should be able to do it in my head, shouldn't I? 210 equals 210. 5 times 2, yeah, okay. Sorry, my brain's frozen here today. This now cancels out. I have -7 erasers equals 10301, is that right? 9, 10, yeah, 301. So 7 goes into that. This is hold on 1 second. What am I doing incorrectly? Because we can't have a negative number. Oh, because I did about -5. There we go. Who caught that? If you caught that, you got the right answer. When I multiply this by -5, it became -210. And thank you for catching that. And that would be 9. And that would be 11. So 119 looks like a better answer. Yeah, so now let's see if that's negative. Negatives now cancel out. We have 7e equals 119. Divide by 7, divide by 7. 7 goes into that one time with 49 left over with the 4, and that'd be 7. So the erasers cost 17 cents. And once you have 17 cents, you can plug it back into either one of the problems, and you should solve for the cost of the pencils. Did you catch that? Who caught that? Honestly, raise your hand if you caught that. I didn't get that 210 negative up top, and herein lies the problem. All right, let's go on to the next page, page number 20. And I'm going to do this for about 45 minutes to an hour. If I get to where I'm not quite done with the book, I might give you more stuff next week, and I got to get ready for some things tonight here at the Iglesias. So let's look at page 20. You can read the top. They've probably done a few of these for you, I would imagine. So let me do this. Let me do the one below the top one on the left where it says 3x plus 4y equals 11. And if they've already done this one for you, then I'll at least show you one of the ones that they've already done for you. So now what we're going to do is we have to get rid of either the x or the y because we only have one unknown value. So let's look at this problem. Let's find out the best thing to do. In my humble opinion, there's 4 different ways you can do this problem, even more than that actually. In my humble opinion, the best thing to do is to multiply the entire bottom by a -2. The reason being is this. It'll turn this 2 into 4 negative and it'll get rid of it. So I'm choosing to multiply the entire bottom by -2 so I can cross out the y's so I just have the x's, and once I have one value I can solve for both values because you can't solve for 2 values unless you can eliminate one of them. So when I do that, let me write it here also, 3x plus 4y equals 11. I'm going to multiply this by -2, so that's -10x minus 4y equals a plus 10, right? Because the reason it's plus is because I multiplied a -5 by a -2. I'm not going to make that mistake again. And now the 4's can cancel out, right? Now I have a -7x equals 21. X is going to equal negative 3. I won't solve that because you know how to do that, hopefully. If you don't know how to do that and get negative 3, then we're a little bit advanced beyond you. So that's how you do that one. And they might not even want you to solve these yet, do they? What do they want you to do? Let's see what they say. Replace each system of equations with an equivalent system which you would solve by addition and subtraction. You do not need to solve them. Hey, look at that. And we don't even need to solve them. So, again, you can use any ones you want to. You can even just do it to there. Then you know you'll eliminate them. So you're not even have to solve that yet. Let's see if there's one where they both have to be multiplied together. I don't see anything like that. Okay. All right, there's a couple different ways to do those, and you just need to do the best one for you. Let's go on to page 21. So really you're telling you what you're multiplying it by. On that one we did by a negative 2 in order to get rid of those 4s, those 4 y's. Let's go on to page 21. It says solve by addition or subtraction. So let's go 7x plus 2y. Did they do this one for you? They may have. I'll do a different one just in case, because it'd be travesty if I didn't do one of your problems for you. Let's do the one right below that. 3x plus 4y equals 11. And 5x plus 2y, this one we just did on the other side. That's the exact same problem. I've already done that one for you. Let's do the one right below that, since I have already done that exact problem for you. Didn't know that. We have 4x plus 3y equals, how are we doing? All right. 7. We have 2x minus 9y equals 35. Okay, so let's look at this problem. Put it on the board for you there. And seems like the smartest thing in my estimation would be to multiply the entire top by, what is it? 3, absolutely. Good, whoever said that, good job. The reason I multiply the entire top by 3, it makes the y on the top equation a 9y. There's a negative 9y on the bottom equation, and so what you'll have then is you'll be able to get rid of, so let me do this. I'm going to do it right here. I'll do it above. So 4 times 3 is 12x plus 9y equals, I'm multiplying by 3, so 21. Okay? Now let me erase this middle part, and then we solve for x. Because I did that, I multiplied by 3, I created that as 9y. This is a negative 9y. These y's cancel out. I have 14x equals 56. And divide by 14, divide by 14. How many times is 14 going to 56? 4 times maybe? Or is it 66? What did I do wrong? 14 going to 56 evenly? Probably does, yes. Let me see, 14 to 56. My brain is fried. It's got to be 4 times, right? Yeah. Yeah, 4 times. I was thinking 16 because of the square roots and stuff like that. So our answer, x equals 4. If x equals 4, you just put it back in any of these problems. Let's put it here. This is 8 minus 9y equals 35. Subtract 8, subtract 8. Negative 9y equals a 27. So y equals a negative 3. So x equals 4, y equals negative 3. There you go, dudes. All right, you can do the rest of that page because you're smart. If you have any questions, you may email me. Be happy to help you. If you're not grasping the concept, we can help you out. Let's go on to the next page. A calculator may be helpful. I'm not sure why you'd want a calculator, but that's okay. Page 22, maybe because there's higher numbers. Let's go ahead and do the 5x minus 4y equals 10. And I'm going to put a little space in between just so I can write them closer to each other. 3x minus 2y equals 6. Okay, so what I want to do here, I can't multiply the whole bottom by a 2 because the negative 4y on the top is negative and the 2y on the bottom is negative. So really what I need to do is I need to multiply the entire bottom by a what? By a negative 2, exactly, because that will make that 2y a positive 4y. Again, our whole goal is to make this and this exactly opposite, meaning a minus and a plus or a plus and a minus, so they can cancel out. That's what our goal is. Excuse me, I didn't mean to cough right into your thing. So let's do that. Everything here I'm going to multiply by negative 2. Negative 6x plus 4y equals negative 12. Okay? Let me erase this. Let me solve now. You see by multiplying by a negative 2, I create this a positive 4. Now that cancels out. I have negative x equals negative 2, x equals 2. I plug it back into any of the problems. 10 minus 4y equals 10. Subtract 10, subtract 10. That's 0. So y is going to equal 0. X equals 2, y is going to equal 0. And there we have it. Absolutely correct. Mundo. All right, let's look at the very bottom one. Why don't you try it while I do it, the very bottom one, and see if you can do it, and we'll make sure we get the correct answer together. I'll just be sitting here working on this while you do it as well, and I won't talk because you need the quiet. Hi, how you doing? Good to see you. I'm just teaching algebra. I heard somebody, I didn't know who it was. I'm doing the video. I'm all by myself, but yeah, so. All righty. Loads of fun. Let me say something real quick to Tammy. Jeff has that gift card of $100 to help pay for that stuff, so make sure you get that from him. Perfect. Smart. Sorry about that. I gave you some time to work on this, right? Let's multiply. What am I going to do? I'm going to personally multiply everything on the top by a negative 60. And so 20 times 60 is what, 1,200? I think. Yeah, 1,200. So this cancels out. This becomes 15y. This becomes 1,200, negative 1,200. So this is going to be 60. So y is going to equal 4. If y equals 4, let's just put it back in this original problem. X equals 16, right? Is that right? Let me make sure I'm right. Yeah. So x equals 6, y equals 4, x equals 16. There we go. All righty. Very fun. How'd you do? Good. I'm glad you did well. Anybody lost? All right, let's go on to the next page. Page 23. They have decimals in here. Let's do this 0.3x plus 0.2y equals 2.5 over x minus 2y equals a negative 5. That's the second one off to the right-hand side. So I have 0.3x plus 0.2y equals 2.5 over x minus 2y equals negative 5. Okay, so let's do this. All we really need to do then is multiply the entire top by 10, right? Because what if I multiply by 10, you just move the decimal to there, want to express it. Goes from there to there, but want to express it, go there to there. Okay, so now I've multiplied the entire top by 10, and I've just moved each decimal place over one time. And now I have a number on the top that can be subtracted from the number on the bottom. So that cancels out. I have 4x equals 20, x equals 5. If x equals 5, 5 minus 2y equals negative 5. Subtract 5, that's negative 10. Negative 2y equals negative 10, y equals a positive 5. So y equals 5 and x equals 5. Easy squeezy lemon cheesy, right? Absolutely it is. Absolutely. Alrighty. Same thing on all those. For example, on the 2x minus 3y equals 4, just move the decimal point over 2 times on both of those. Then you'll have to actually do it by a negative also. So go the 0.02x, just move it over 2 times to make it 2x, then go minus, minus, minus all the way across, and that way you can have your final answer there. All right. That's page 23. We're on page 24. Sometimes you have to multiply both top and bottom. And page 24, they're not even asking you to get an answer. They're just asking you to figure out what you're going to multiply by. And I'll show you how to do a couple of those, or at least one of those. And really, on 24, you're not doing, it's kind of like that other page, that, not 20 or whatever, yeah, page 20. So you have the top one, they probably did for you, so 7x minus 6y equals, 10. And then 2x plus 5y equals 23. Okay, so what we're going to want to do is this. There's several different things you can do, but you want to get, probably the easiest thing to do is because this is already a minus, and this is already a plus, and these two are both pluses, I mean they're already opposite signs. If I multiply the entire top by 5, I would make this a negative 30y. If I multiply the entire bottom by 6, I make this a positive 30y, and then they'd cancel out. So the entire top times 5, entire bottom times 6, and then solve for the x that you have left over. Okay? That's probably, you could also do, because 2 doesn't go into 7 evenly, and 7, 5 and 6 don't go into each other evenly, so you have to multiply both, kind of by like the least common multiple of the two. And so you got to get the 5s and the 6s to 30. Bang, buzz, 7's 14. And all right, so let's erase this and go on to the next page and actually do a few. We actually have that problem. This is the second problem on the next page. So let's go ahead and do it, because we already started to do it. What I'm going to do here is I'm going to bring this one down here and bring this one up here, then erase those two. Make sense? So I've already figured out that I need to multiply the entire top here by 5, and then the entire bottom by 6. Okay? So this becomes 35x minus 30y equals 50. This becomes 12x plus 30y equals 23 times 6. You think I know how to do that. 138. Okay. Now I have a problem I can work, right? I took that original problem with 2 unknown values of x and y, and I've turned them into a problem I can work out. I can now get rid of the y, so I only have one unknown value, which is x. 35, 45, 47 equals x equals 188. Divide by 47, divide by 47. I hope I did that right. I'd be very embarrassed if I didn't. And yeah, 47, 7 times 4, yeah, so x equals 4. 188 divided by 47 is 4. You can take this and put it back in any of these problems, or you can put it back in the original problems, which might be easier. Probably shouldn't have erased them, because then you're not dealing with such high numbers. And so the original problem looked like this. I'll just do the bottom one, which is 2x plus 5y equals 23. And so we said x is worth 4, so 8 plus 5y equals 23. Subtract 8, subtract 8. And, oh, hold on one second. Is that right? Hold on one second. Hold on one second. Yeah, that's right. So x equals, or 5y equals 15. So y equals 3. Because 5 goes into 15 3 times. So x equals 4, y equals 3. And we are absolutely 100% correctamundo there. Woo! Fun, fun, fun. That is fun. Let's go on to, we're actually cruising right nicely here. We only have about 6 or 7 more pages, maybe 10 more pages. Let's see what time we have. I'm doing well. Let's keep on going. If you need to stop and just kind of memorize the time score, write it down, and you can come back on later and say I'm at 23 minutes and 12 seconds or whatever it would be. And so let's go on to page 26. It's more of the same, but you can choose which one you want to use. Actually, they're all going to be adding and subtracting. So let me do one more of those for you. These are all the same. I'll do the very last one. 5x plus 2y equals 5x plus 2y equals 9. And then you have 2x plus 3y equals negative 3. So let's do this. Let's multiply the top by 3 and the bottom by negative 2. See what happens if we do that. So this is 15x plus 6y equals 27. And this is negative 4x minus 6y equals a positive 6. All right, this cancels out. Now I have 11x equals 33. X equals 3. If x equals 3, let's go 2 times 3 plus 3y equals a negative 3. So that's 6. Subtract 6, subtract 6. That's would be 3y equals a negative 9. So y equals a negative 3. I'm not going to do all that. Cross out. You know how to do that, right? So x equals 3, y equals negative 3, and that's the correct answer. All right, page 27. Let me show you how to do one of those. And that way you can do all 4 of them. Let's do the bottom left. 4x plus y equals 3. And then we have 3x plus 5y equals negative 19. Okay, so let's do this. Let's get the y by itself and then substitute it back in here because they want you to do it that way just so you can try it. You could stack them like we've been doing, but let's try to do substitution now. So to get y by itself, I go y equals 3 minus 4x. Y'all see how I got that? I just subtracted 4x from both sides. It got rid of it there. Now I have y all by itself. So I've converted this problem into this problem. Why did I do that? So now I have y all by itself, and I can substitute this for that, because they mean the same, right? They're equals to each other. Equals. They're equal to each other. 3x plus 5 times 3 minus 4x equals negative 19. Okay? So I got y by itself. Once I got y by itself, I substituted it in here. I need to multiply the 5 by both this and by that, because that's the distributive property. And so let me now solve for that. So I have 3x plus 15 minus 12x equals a negative 19. And I'm now going to combine the x's. Negative 9x, subtract 15, and I'm going to, is that going to be right there? What did I do wrong? Did I do something wrong? This is 3 times 5, this is negative 12x. This is 9x. This is negative 19. Somehow I did something wrong. Look at my original problem, see what I did wrong here. just solve, make sure I'm not wrong. It looks like I'm wrong, though. So this is going to be 9 and 15 is going to be 4, 34, right? Yeah, see, that can't be right because it's negative 19, 15. All right, let me start over. Sometimes that happens in math. Not sure what I did wrong. Write the original problem again. Looks like this. 4x plus y equals 3. 3, okay. So I subtract 4x from both sides. Yes, I should get that. 3x, make sure I wrote that down right. 3x plus 5y. 3x plus 5 times 3 minus, 20. Duh. That's what I did wrong. Did you catch that? Somebody caught that. Sorry about that. Got it. We're good. I did everything right. This is 3x plus 15 minus 20x equals negative 19. There we go. Mucho más bueno. Mucho más bueno. So that's going to make this going to be now 17x negative equals negative 34. And x is going to equal positive 2. And if x equals positive 2, we have 3. 2 plus 5y equals negative 19. 6 plus 5y equals negative 19. 5y equals negative 25. Y equals negative 5. There we go. X equals 2, y equals negative 5. Sorry about that. Did you catch the 5 times 4? I did the 5 times 3, I guess. I'm not sure what I did. No, I did 4 times 3. I don't know what I did. Who knows what I did, but I got it right now, so there we go. And that's how you do that problem. Same exact way on all the other ones, just don't. If you mess up, it happens sometimes. All these are going to go unevenly. The reason I thought I messed up is because I knew 15 was a multiple of 3, and I had 3 left over there, and I thought that's not going to work out because 19's not. And so I caught myself and then figured it out. Right, Roman? Ramen noodles? Are we having any? Is Penelope Pit Stop there? I taught Penelope Pit Stop years ago in this very subject, but a different curriculum. All right, let's go on to page number 28. Yikes, we have more word problems, and then we have in solving inequalities, which looks really difficult, but we don't think it's too hard. Maybe I'll stop here and give you some more teaching tomorrow. That way I can get my stuff done. So what we're going to do is we're going to stop right there. We'll get you through page 27. So we taught you 18 through 27, and then we'll get you 28, 29, 30, 31, 32, 33, 34. Probably tomorrow, maybe Friday. Try to get it to you before your spring break. By the way, tentatively, what we would do is tomorrow would have been the last day before spring break because we have Thursday class, and then we had the next 2 weeks off. But we kind of missed a week in there because once everything started shutting down, it kind of took us a week to get going. So if I get it to you next Monday, it's not the end of the world, or Tuesday even. And but anyways, you have enough to do now. We got to get through book 9, then through book 10. I like book 10 better. Fun book. It's exponents and things of that nature, and some other stuff I can't quite remember. It's been a year since I've done it, but I thumbed through it. So anyways, Mr. Soto, signing off.